In this video, I'm going to review with you how to graph an exponential function, and then we're going to talk about how to graph our new function of a log function. So example 1 says, consider the function y equals 3 to the x plus 1. Identify the parent function and describe the transformations. So remember, a parent function is a function with no transformations. So in this case, our parent function is y equals 3 to the x, and there was this plus 1 on the outside, so it was translated up 1 unit. If it was a minus, it would have been down. If it was in the exponent on the inside, that means it's going left or right. Part B is asking us to sketch the graph. So I'm going to go to my calculator and I'm going to copy down a table of values to plot my points. Now there is no restricted domain. It's not telling me to start or stop at a specific value. So that means that after I copy down my table of values, I'm going to make sure to graph with arrows on the ends. So 3 to the x plus 1, making sure to hit the right arrow to get outside of the exponent before I put that plus 1 in. I'm going to go to my table. I'm going to copy down a few numbers. So I have -2, let's say, to 2. Two, 4, and 10. Okay, so here is my table of values. And I'm going to plot my points. Now my decimals, I'm just estimating, so 1.3 is in between 1 and 2. Same thing's happening here. Now, before I go to connect, I'm going to hit zoom 6, which is my standard window, and I want to take a look at that picture. Remember that this is an exponential function, so it is leveling off. So if I go to the worksheet, part C says state the equation of the asymptote. I'm actually going to do that first because I want to put that in on my graph. Remember that an asymptote is something that you will approach but never touch. It's like a fence. So I want to make sure I have that sketched in on my graph so I don't cross over it when I go to connect my points. Your asymptote you can find from the equation or the cheat on your calculator. So from my equation, I moved up 1. That plus 1 is my asymptote, y equals 1. And I'm going to sketch that in here with a dotted line for my asymptote. The cheat on my calculator would be to go to the table, and I'm going to continue to scroll up, and it gets closer and closer to 1. And while your calculator may say that it's getting to 1 and they start to repeat here, that's not actually happening. It's just rounding to 1. So now I can go back to my graph. I can connect them, making sure to include arrows on the ends, and I'm going to label it. And then let's just finish with these follow-up questions. State any intercepts. So I have a y-intercept here in my table or on my graph. My y-intercept is 0, 2. And there are no x-intercepts because it never goes below y equals 1. My domain, which is my x values, is how far left and how far right my graph goes. For any exponential function that will never change, it's -infinity to +infinity. My range, however, does change. That's based on my asymptote. The lowest point that this graph will ever go is 1. It will never go below that asymptote. I do, however, have an arrow pointing up, so the highest is to infinity. And then lastly, is this function increasing or decreasing? This is an increasing function. My y values are going up, my graph is going up, and it is an exponential growth. So this is a review of exponential functions. Exponential functions are related to log functions. So example 2 is about a log function. Consider the function y equals log base 3 of x minus 1. Same questions to follow up. I'm starting with my parent function, which remember is my original function with no transformations. So my parent function is y equals log base 3 of x. And what changed here is this minus 1 on the inside. So that means it was translated. Left and right is inside my parentheses. And when I'm inside, it's always the opposite. So although it's a minus 1, it is actually translated right 1 unit. Now, of course, I need to sketch my graph again. So I'm going to go to my calculator. I'm going to go back to my y equals, clear out what I have there. I have a log with a different base, so I can't use the log button on the calculator right next to the 7 because I would not have the opportunity then to put that base of 3 in. So instead, we go to Alpha, Window, and we choose Choice 5. And now I have the opportunity to put that 3 there. I'm going to hit the right arrow to get out of my base, and inside my parentheses is x minus 1. I'm going to go to my table, and I have all these errors because, remember, I had scrolled to talk about my asymptote before. So I'm going to copy down some of these numbers. They're not going to be great. I don't want to copy down all of these decimals, so I'm actually going to use any of my numbers that don't have decimals, and I'm also going to copy down this first error value here. So 1 has an error, 2, 0, 4, 1, and 10, 2. Those are my other numbers that were plausible to graph, considering what they gave me here. Remember, if they want to see specific things, you're going to have to sketch or scale your graph differently. So I'm going to plot these points, 2, 0, 4, 1, and 10, 2. Once again, I'm going to go to my asymptote first because an asymptote, I don't want to cross over it. So I want to make sure I have that on my graph first. So let's look at our graph as well. Your asymptote for a log function is always going to be an x equals. For our exponential function, it was a y equals because it was a horizontal line. For logs, it's an asymptote x equals because it is a vertical line. And here, it's going to be at x equals 1. So the parent function is always on the axes, but in this case, I moved right 1 because of this inside minus 1. So my equation for my asymptote is x equals 1, and I'm not going to cross over that. On the calculator side, or the cheat way, it's the first number with the error. So my asymptote is x equals 1 because that's where my error shows up. And now I can go ahead and connect my graph, adding arrows on the ends because they didn't tell me where to start or where to stop. And let's just finish our follow-up questions. I'm identifying any intercepts. So this time I have an x-intercept in my table here or on my graph there. It's 2, 0. I don't have a y-intercept because it is not going past that vertical fence that I have there on my graph, my asymptote of x equals 1. My domain is going to be for logs from my asymptote of 1 to infinity. My range for all log functions is not going to change. It's negative infinity to positive infinity. So if you notice, most of the logs and exponential rules are opposite. My exponentials, I don't have x-intercepts most times. My logs, I don't have y-intercepts most times. X equals versus y equals on the asymptote. In exponential functions, my domain is always all real numbers. For logs, my range is always all real numbers. And then is this function increasing or decreasing? This is an increasing function. So this is a very quick, brief example to introduce you to log graphs, but we will see all different kinds as well as we do more practice in class.